Hello, we are going to do lesson 35 video notes, and we're going to talk about the application of quadratics today. And application means, in some people translate this to word problems, but we're going to show you how the special features of a parabola are going to help you solve application problems in quadratics. So let's talk about applications in the real world. Quadratics can be utilized in many situations between roots, axis of symmetry. These are all vocabulary words that we're going to use. You should write them in your notes for today. And vertex application. These characteristics are frequent. Anytime you kick a soccer ball, it goes in an arch, and that is already a quadratic. When quadratic functions are used to model real-world situation, their maximum and minimum values have real-world meanings. And this concept that you have a maximum and a minimum of a quadratic is going to be used in your higher math courses as well. So let's talk about a very special part of quadratics, maximums and minimums. We know that a vertex is either the maximum or minimum of a quadratic. So what point on the graph of a quadratic is defined as the maximum or minimum? And then you probably know this, but this is the vertex. So you can go ahead and pause this video and write this part down. This connection between the minimum and maximum and vertex is the key to getting many of these problems correct. The other ways to solve these types of application problems is finding zeros or roots or y-intercepts, and these are the types of questions that some of you did in Algebra 1 last year at LPS. So here are your steps. A lot of these application problems don't have step-by-step procedures, but these general steps will help you solve problems, and these are tips. So you can also pause the video and write these down, and then we're going to identify when we use these steps in the following two problems. Step 1, identify the variables. Write your let statement. So I'm going to show you how to write let statements. Underline given numerical information, translate words to equations, and then solve the system of equations. Find the find. We're going to identify what our find is, and then we're going to find our find. So in our example, we have a rectangle is formed by increasing one dimension of a square by 3 units while decreasing the other by 3 units. If the original side length of the square is represented by x, which of the following represents the area of the newly formed rectangle? So this says which of the following because this was a multiple choice question, but I just took that part out. So I'm going to say what equation represents the area of the newly formed rectangle? So let's write some let statements. Step 1, let's write some let statements. Let x equal, let's see, the original side length of the square is represented by x. Oh, okay. Let x equal the original side length. And then you may be like, what are we even dealing with? We're dealing with a square. A square, the original length for both sides of a square is x. Now, a rectangle is going to form because now it's going to get transformed into a rectangle. So one side is going to get smaller and one side is going to get bigger. But the area is going to be made from the length times the width. We know area is equal to length times width. Right now, our length and width is x and x. Okay, so our new rectangle is going to be x, 3 units increasing. So this is, we're going to underline numerical information, increasing by 3 units. That means plus 3 units. The other side is decreasing by 3 units. That means minus 3 units. So I'm underlining numerical information, and then I already crossed out what I don't need. And now we just have to translate given information from sentence to an equation. This is probably the most difficult step. So if you need help, usually you're stuck on step 4. So one side is going to increase by 3 units, and the other side is going to decrease by 3 units. So our area is our length times our width. which is x plus 3, x minus 3, or x squared minus 9. So in your notes, you should have the steps written down. You should identify which step belongs in which part of the question. You should have the question written down and your pictures drawn so that you can take notes and then annotate them. Which part are you going to get stuck on? Do you have trouble going from this step to this step? Write it down.